Hey students, so in this video I'm going to explain how to do these problems that talk about focus and directrix. This example right here says to write an equation of a parabola given the vertex of -1, -5. So please start by plotting that so you can visualize what the parabola looks like. So -1, -5 is around here. And let's label that the V for vertex. Then we have a directrix at x equals 4, sorry. So whenever you're confused if x equals 4 is a horizontal or vertical line, just visualize plotting a lot of values that have x equals 4 in them. So when we have a point here, that will be x equals 4. If we have another point with x equals 4, we're going to have it up here. And then another one here. So it starts creating that vertical line of x equals 4. From there, we can remember that the parabola needs to open a certain way, for example, right here, where the directrix is never going to be touched by the parabola. So this one has an example of how a directrix being vertical, the parabola needs to look like it opens to the left in order for that directrix to not be touched. So we have something similar to that happening here. We're going to have a parabola opening to the left, so it never touches the directrix. Then from there, that's all the information we're given. So your job is to remember that the vertex and the directrix have a relationship where whatever amount of spaces you have here, that is also the amount of spaces you have towards the focus. So we have 5 spaces to the right, so we're going to do 5 spaces to the left. 1, 2, 3, 4, 5. And this is the focus. So the vertex will be -1, -5. The focus will be -6, -5. The directrix is what they give you, so x equals 4. And then the axis of symmetry is that line that cuts the parabola in half. So it's going to be at y equals, and then it's touching at -5. To write an equation for this, you need to recall the template of the equation. It's either going to be the regular vertex form, and that's when it opens up and down, or it's going to be the switch version of the vertex form, and that's when it opens left and right. So this is opening sideways, so we're going to use this template right here. X equals a y minus k squared plus h. And everything that needs to be substituted is the a, k, and h. A, as mentioned up here, is a value that is calculated with the formula of 1/4p. P is the distance from the vertex to the focus, or from the vertex to the directrix. So we have the vertex to the directrix right here, and that was 5 spaces. So that's your P. So knowing that the P is 5, we're going to look at it as 1/4 times 5, and that's 20. So your A value ends up being 1/20. So I'm just going to write that down right here. 1/4p. We put that p value in there, so 1/4 times 5. And that ends up being 1/20. So that is your A value in the equation. So we're going to have x equals 1/20. Y minus h and k come from the vertex. So this is the h, this is the k. K is -5, so we put minus -5. That's going to be plus 5. Plus h. H is -1, so we're going to put -1. We are almost done. The last thing you want to verify is that you have the correct A value in terms of positive and negative. So one way to remember, of course, is looking at the notes, but if it opens to the right, you can also remember that the x values on the right side are positive. So that's a positive A. If it opens to the left, the left values of the x-axis are negative, so that's why it's a negative A. That's the way to remember. So this one opens to the left, so we need to have that -A. So that's the equation that was created for this graph. And you can always use your calculator to verify. If you want to graph an equation that starts with x equals, you want to go to menu, graph, and instead of function, we're going to do relation. And then we type x equals negative 1 over 20, y plus 5 squared minus 1. And it creates that graph of turning to the left, opening to the left. We can always zoom out and change the view if you want to see it differently. And then pretty much just confirms that it's sideways. If you want to confirm that it has a correct vertex, you can always trace it. So you were looking for negative 1, negative 5 as your turning point. And then the directrix can also be confirmed in Analyze Graph. We're going to go to Analyze Conics. And then the directrix is right there, number 5. So you scroll over the graph, and then it's right there, x equals 4. All right, so this is the equation for this information. I'll quickly go over this example. Following this, you can pause the video and then do it yourself, and then just verify that you did it correctly. So the vertex is 3 over 3 and 4. The directrix is y equals 7, so we're going to go to 7 and write a line. And because this is a directrix, it's not touched by the parabola, we're going to have a parabola going down. We're looking for the focus and axis of symmetry. So we know that the axis of symmetry cuts through the middle. It's going to cut at 3. So we're going to say x equals 3. The directrix is y equals 7 because it was given to you. The vertex was given to you as well, so it's 3, 4. And then the focus is calculated by counting the spaces and then keep going this way. So this is the focus right here. And it's going to be 3, 1. For the equation, we're going to remember that this is going to be this template right here because it opens down. And then we need to calculate the A value. A value is 1 over 4p. P is 1, 2, 3 spaces, and we put a 3 in there. That's 4 times 3. So it ends up with 1 over 12. So we're going to have 1 over 12. It is facing down or opening down, so it's a negative A. X minus your H plus K. And that's the equation. All right, hope this video helps you.